This is a mask testing device that I made as an honors project for one of my classes this semester. It has a particle sensor that detects from a range of 0.3 to 10 micrometers, 2 temperature, pressure, and humidity sensors, this one being jumpered to give it a different address, an SD card device, an LED to serve as a UI, and also a button to be able to control it. This is all being run off of an Arduino Uno. Now the idea is one sensor sits outside with the ambient environment and the other sitting inside the user's mask. Both read different pressures on the instance of a cough. Now the difference in these pressures, I feel, is a good way to objectively measure the comfortability of these masks, as the breathability is kind of indicated by the difference in pressure. You know, when you breathe or cough, how much resistance is there? The idea of the program running on the Arduino is that through the UI system, eventually, a file will open on here that the user can write as many tests as they would like to said file. The idea, the tests each would be in a different environment to try and figure out the trends between the particles detected and the temperature, or the particles detected and the humidity, then calculating a linear regression and an R-squared value for that linear regression. To add tests, the user would hold down the button once it was in standby mode, starting a new test, and each test has 5 trials. It takes the average of those 5 trials, as obviously none of this is world-class equipment. A 3, 2, 1, 0 count will be given from the LED, and on 0, the user would be expected to cough into here, in this case me, and I will do one set without a mask and one set with a mask. One in my room where it's really, really cold right now, one out in the house where it's normal temperature, and one outside where it's mildly hot and pretty humid. And that way we'll have 3 pretty separate data points to make a good trend line. And by good, I mean good for the fact that this project really isn't about finding those correlations and more just about writing a program that does it. So, on plugging in the thing, I've set up right now where you see there's a few blinks. Now the 2 blinks here indicating that this particle sensor is not correctly set up. Now the reason it's blinking twice is just because it didn't have enough setup time that time, and I can just reset it and it'll be fine. It just needed a second to boot up. But for each of these there is a different amount of blinks where this LED serves as the UI to show, hey, which of these devices is not working properly before you get started. So we will get started here and use this button, pulling it down, get into standby mode. So now we're in standby mode, it's blinking to let you know, and then we will open a file and start a test. All the tests will go onto one of these files, and the files, it looks through all the files already on there, and then it uses a numbering system to basically decide what the name of the new file will be automatically, so I don't have to name them. So hold it down for a long time, let go, and then we'll start getting the 3, 2, 1s. Now we're back in standby mode and we can do another test. So let's go do one out in the hallway where it's a little more humid and a little bit warmer. And now we're outside in the dank Indiana spring. And there we go. There's all 3 tests. And now we will do part 2, testing a surgical mask. And once again, the idea with collecting the temperature and humidity data is not only the infectious disease spreading differently depending on the air quality, but also with the pandemic starting, there is so much more of a variety of masks that you can buy on the market. And I imagine that the materials also have somewhat of effect simply because anything changes size with different temperature. And also, things absorb water in the air differently, so humidity could also affect the masks itself, not just the way that the particles travel through the air. So, let's see how this one works. Put it on. put sensor on the side here, and then start a new thing. Standby menu, open a new file, and start test 1. The search to search through the mask, to add a test file, and a go button, which serves the purpose of multiple things, which is why that pseudo state machine was needed. But you can see, if I search for something that isn't there, it'll get angry at me, but there's nothing there at all. So I need to add a mask test file, and you get this other lovely little pop-up. Now, I will name this one no mask, because that's the first thing we did. And I believe that was M12. So, can't append it to anything because there's nothing there. Add new. There is our no mask. While I'm here, I'll add the surgical mask. Oops. So the surgical mask was 13. Add that one. Lovely. So now we can look at them. I'll select 1. It gives me all the options. Select none, goes back to nothing. Select 1, same thing. Now if I select 2, then it gives me this option to say, hey, what would the value be at any arbitrary value I could imagine? So I want to know what would be of the two more effective, wearing a mask or not wearing a mask, if it is. So then I put in my arbitrary values to see, hey, what would it be like between these two masks? As you can see, I have the arbitrary value representing its effectiveness there, and to no surprise, the surgical mask is higher. Then you can see, just as one would expect, the comfort of no mask is better. There's a much smaller difference in pressure between the inside and the outside of the mask because, well, there really isn't one. And then you can see the two effectiveness values. It highlights which one is better between the two and different. Little explanation at the top. But I want to just show the effectiveness. But I just want to show the functionality of one. So we'll go back to selecting 1 and that state machine handling all the differences in the UI for me. And I'll just show the collected data. Here's that data. It's the same data that was collected in that CSV, but was pretty hard to interpret. So here we know the inside temperature, the outside temperature, all of that stuff. The difference in pressure, and the number of particles of each size. Then, out of these 3 options, let's just show a temperature versus particle regression, because I was inside my cold room in the lukewarm house, and then outside where it was kind of toasty. So we'll look at that. And here's the linear regression we got from that. It shows the R² value. That's pretty solid. But also, there's really only 3 data points. But let's say, hey, I don't know, what if it was really cold? We'll do, I don't know, 10 degrees Celsius. How many particles would I expect? With that mask, okay, approximately that much. What if it's smack dab in the middle of all my values? Okay, there it is, and the interpolation result is shown down there. I can just exit out of this, go back. I could show any other, but I think I will show the search functionality. So I will search for no mask. And you may not be able to tell, but it did find it. As I click here, now this is not the one we were just looking at. This is the no mask. Not as good of a line fit there, but as you can see, the search works and it goes back to white, that it's not in an error state anymore. Then I can exit, it'll save. There's the output file it just created. All the objects are serialized. Then open it again, and they will all be there as expected with all of the functionality that was there before. And just as well, even though they're all there, I'd like to say, hey, I want to add another file. I have a bunch of files already in there from before, so I think I will just append it. So I will append to the surgical mask just so you can see that it works. I will append, let's say, M2, all of those values. Is there an M2? Yeah. Append to that. You can see its value instantly changed. Thank you to that state machine. Then I'll add 3 to it as well. I'll append it. And just for kicks, I'll append M9 to it as well. So now let's take a look at that one alone, show the collected data, and now you can see after appending 3 more files worth, I have 12 rows of data. Then let's look at those regressions. We have a lot more data points, a lot more down here because this is about the temperature of my room normally, so those are all of those, and everything works just the same.